It's my pleasure to introduce Dr. Danae and Metaxa. They are an incoming assistant professor of computer and information science at the University of Pennsylvania. The secondary appointment in Standford School of Communication. Dr. Metaxa received a PhD in computer science from Stanford University in 2021 and is currently a postdoctoral research at Stanford Center for Philanthropy and Civil Society, mentored by Dr. Nathaniel Presley, and working on the Program for Democracy and Age Grant. Previously, Danae received dual undergraduate BA degrees from Brown University, Computer Science and Science and Society. During their academic career, they've had the honor of being recognized by several awards, including an NSF Graduate Fellowship and a Native Born Memorial Scholarship from Google. The research has been published and awarded at top science conference venues, including PHI and CSCW. With that, and we can begin.
Hi, everyone. Thank you so much for the introduction. And let me just open a screen sharing here. I was just saying, I realized I've given some version of this talk so many times at this point after being on the job market this year, and not a single time in person. So we're just going to continue that. All right, everyone can see slides okay?
Yep.
Great. Thank you so much. So again, thank you for being here today and for having me. My name is Danae Metaxa, and I'm really thrilled to be joining this seminar series, not in the least because I'll be starting as an assistant professor next fall at Penn. So it's nice to sort of start getting to know some names or faces at this point early on. And today I'm going to be talking about some of the work that I've done during my PhD, focusing on bias and representation in sociotechnical systems. So let's just jump right in. To introduce this first project, I wanted to give you a little background about how I arrived at the topic of study. So the computer science department at Brown, where I did my undergraduate degrees, has a tradition of giving each course a fun theme every year. And this was generally a really popular move with students. There were pop culture topics like TV shows or comics. And I really enjoyed most of these themes myself, but I did find that some of these were like a little intense. So, there was this James Bond theme, although honestly, that's a pretty clever theme for a security class. Or this one that was modeled after Star Trek. Or especially, this was my least favorite, this Matrix theme that gets worse, actually. I hope you can see this animation. This animation actually ran in the background of the website at all times. So these were all real course websites while I was at Brown. And, far be it for me to say that I had any issue with the Matrix or Star Trek, but it was that despite this fun environment, I had noticed as someone who was underrepresented in the department that a lot of my friends in those courses were dropping out of the courses or dropping out of the major. And this seemed especially true for my women classmates. And there were also very few women on the faculty or teaching assistants. So given all of that context, some of these websites kind of gave me a sense of intuitive unease. I knew this didn't have anything to do with the material of the course, but it was still there. So years later, when I started my PhD, I came across a concept from psychology that helped me give language to that intuition. Ambient belonging is this term that describes the feeling of fitting in with a culture or a community that's passively elicited by the surrounding environment. It's a psychological concept that comes from a broader literature on belongingness that goes back to Abraham Maslow's hierarchy of needs. So belongingness describes the psychological need to be accepted as a member of a group. And so at the start of my PhD, I found this prior research that had examined ambient belonging in physical spaces like professors' offices. Cherry and et al. Found that students' sense of belonging can be negatively impacted by classroom cues. So stereotypical cues in offices and classrooms, like what books are on the table or what posters are on the wall, could have a negative effect on potential students, in particular students from marginalized groups. Now, obviously, classrooms and offices are immersive and they reflect personal information about an instructor in a way that websites aren't and don't. But based on that idea, I decided to design an experiment to see to what extent ambient belonging was transmitted through a user interface and what effects that might have. So I designed two versions of the same course webpage for an introductory computer science course at Stanford, where I was doing my PhD. The first used neutral imagery and the second one stereotypical imagery. Both of these were designed and pre-tested to look appealing and engaging to students, and the content on the pages was identical, so I only changed the aesthetic design. My hypothesis was that these should have different effects on potential students. So more specifically, that the stereotypical interface would be detrimental to women, but not to men. So that would mean hypothetically producing some results figures that look something like this, comparing these two interfaces, the neutral one in the lighter color and the stereotypical in the darker color. I expected there would be very little difference between those two bars for men, that's the pair on the left, pretty comparable height, but that for women, that's the pair on the right, the stereotypical interface I hypothesized would have this negative impact. And on the y-axis here is a 7-point Likert scale for each of the experimental measures. After interacting with one of these two websites assigned at random, I had participants answer questions on this 7-point Likert scale about a range of measures that included whether they would want to take the course, whether they expected they would feel comfortable in it, how well they expected they would do, but also measures that were beyond the scope of the course. So whether they felt confident in their technical abilities, whether they even wanted to study computer science, and whether they felt they would be judged according to gender stereotypes in the discipline. And I'll note here that rather than potentially negatively impacting a whole cohort of actual Stanford students, I ran this experiment using crowd workers of undergraduate age in the United States. So what I found here was really striking. Starting with these course-related measures, women exposed to the stereotypical website suffered. As you can see, for each of these measures, the rightmost darker bar that corresponds to women who saw the stereotypical website is statistically significantly lower than all of the others in each figure. So this means they reported lower intention to enroll, less sense of belonging, less anticipated success relative to all other participants. And moreover, women who saw that stereotypical website were also negatively impacted on longer term measures. These are ones that ostensibly had little to do with the course. So they said they were less interested in computer science as a field, less confident in their technical abilities, and they expected to be much more stereotyped in the discipline. And these were moderate to large effect sizes that were as large as any in the prior work on ambient belonging in physical spaces. Also, by the way, I think it's just interesting to note here that exposed to the neutral website, if we compare just the lighter green bars in each figure, women's and men's responses were mostly comparable without statistically significant differences. So for a field that really emphasizes its pipeline problem sometimes, it was impressive to me to note that we didn't actually see evidence here of pre-existing differences by gender. So I was able to conclude that gender bias could negatively impact people's sense of belonging in a user interface. But of course, belongingness itself isn't specific to gender. A wide variety of biases can be conveyed visually and impact belonging. So you could consider, for instance, the effect of an image like this one of Paul Ryan's interns when he was Speaker of the House on, say, a young person of color who wants to enter government and whether they see themselves represented in that image. Or maybe this grandiose image from the Rhodes Scholarship website and the effect that that could have on a promising student of lower socioeconomic status who's never stepped foot at a place like Oxford, and that student's sense of belonging in a community like the Rhodes Scholars. Visual cues in online systems can have unanticipated and unintended consequences on users across a range of dimensions. So that project launched further work from other researchers like Renee Kizelkech at Cornell studying psychologically inclusive design. But it also launched the rest of my research focusing on bias in sociotechnical systems and its psychological effects. So what are sociotechnical systems? Broadly, these are systems that shape and are shaped by users. So they interface directly with the user, and in turn, they're often shaped by user behaviors. So this includes search engines and social media sites. And in my work, I close this loop by studying the system and the user. So I combine building systems with behavioral science theory and methods that focus on users to address high-stakes social issues in sociotechnical systems. And in doing that, I'm seeking to answer these two main questions. The first is, what content do sociotechnical systems produce? And the second one is how that content impacts users towards building systems that do better. So traditionally in a software system or even a hardware system, we're used to asking this first question. We know what it means for some system to work, and we conduct tests, we use monitoring to verify that it functions as expected. But sociotechnical systems are in a loop with users. The users are literally part of the system. So it's not enough that the platform just functions. To evaluate these effectively, we also need to ask first what its outputs look like at scale, and second, what influence that has on users. And it's my hope that by answering these two research questions, we can learn how to build sociotechnical systems that have more positive impacts on ourselves and on our communities. Now, before I give you a roadmap for the rest of this talk, let me explain why this work is so particularly challenging. So in this example we started with, comparing two websites, we can see that content that's created by a single person, like a course instructor, can communicate bias and undermine belonging. But this isn't an individual scale problem. Most sociotechnical systems today aren't showing us hand-curated content. They provide us content that's been selected and organized algorithmically. And we rely on this algorithmic content for basic social functions, connection to family and friends, gathering information, civic engagement, and so on. In the United States alone, as of 2019, over 70% of Americans used some type of social media, and a similar proportion got their news through social media. And as of 2012, which is unfortunately the most recent Pew data we have on search engine use, over 90% of online adults use search engines. That's a number we can only imagine is somehow even higher now. And over 2/3 of those searchers considered search engines to be fair and unbiased. But these systems do have significant biases, and we've started to see concern about bias along the lines of gender, race, political affiliation, and more. Studying these systems, going beyond criticism to precisely measure the content that they produce and quantify the impact that this has, remains a challenge. And I see 4 key parts of the problem here, 2 on the side of the system and 2 on the side of the user. So first, these systems are dynamic. They change constantly, and this can pose significant technical challenges in trying to study them. And second, their byproducts are ephemeral. A user's experience of the newsfeed or search engine results disappears without a trace after that interaction, and there's no way to examine it retrospectively. Now, on the side of the user, these systems are embedded. They're a system in a loop with users. So the users are interacting with dozens of these kinds of systems simultaneously in a single browser, on a single device, throughout their daily lives. And finally, they're personal. So each user's view of the system is unique. And in fact, the impact that it can have can be very different from one person to another. So to meet these challenges and close that loop of sociotechnical systems research, we need interdisciplinary solutions that really tackle both sides of this equation. And this is what I do in my work. So in this talk, I'm going to show you what that looks like in practice, touching on 4 projects that I did during my PhD. So first, in the introduction, I described this work on belonging and bias in web interfaces. Next, I'll talk about my most recent work on race and gender representation in image search. Third, I'll bring in some of my work on partisanship in political search results. And finally, I'll describe the final project in my dissertation, building infrastructure for intervention audits. So let's move to that second project. One social issue that's received attention in various fields is visual representation. So in particular, the representation of marginalized people in media. And as I showed in my study of course pages, visual cues impact belonging. In the field of advertising, prior work has shown that representing marginalized people in college brochures can make a university seem more appealing to students. The same has been found to be true for employees at a company or for customers of a business. And these kinds of cues are really important for marginalized people. They indicate that an organization might be more welcoming to them. But importantly, the effects of visual representation aren't restricted to those groups alone. Visual diversity signals inclusivity to everyone. So given the importance of algorithmic systems like search and my interest in visual representation, I was drawn to work on image search results. Do image search results accurately reflect real-world diversity? Prior work from 2015 had identified that search results for occupations exaggerated gender stereotypes. Since then, and often in response to research findings like this one, Google has made a lot of changes to their algorithms. But we might want to ask whether image search results are still biased in their presentation of gender. Moreover, our field has left race chronically understudied. Do image search results reflect real-world racial diversity? To answer these questions, I first needed a ground truth data set with which to compare search results. The US Bureau of Labor Statistics tracks demographic breakdowns of several hundred common occupations, doctors, lawyers, real estate agents, and so on. So based on that BLS list, I set out to collect image search results from Google using as a query term the names of these occupations. And in this introduction, I described the process of identifying bias in hand design content. But of course, in this case, I wanted to study the composition of hundreds of images for hundreds of queries. So this is where studying algorithmic content becomes technically challenging. To accomplish this process, I built infrastructure to collect that algorithmic data. So that pipeline begins with a scraper that queries Google for each of these query terms and captures the resulting top 100 images. To avoid potential personalization from repeated searches, I used a Selenium WebDriver with separate sessions per query. And the scraper saved each image to cloud storage where they were automatically retrieved in the next step, which is data annotation. To annotate this data, I recruited crowd workers through Amazon Mechanical Turk with 3 workers randomly assigned to label each of these 1,000 images. I elected to use crowd workers here rather than automated image processing or machine learning because ultimately I'm interested in how other people perceive these images. And I also have some ongoing work right now thinking about automated labeling of these kinds of cases and when this is appropriate and not. So I'm happy to talk about that more later as well. Now for gender, crowd workers were asked to label whether each image showed a woman or not, and for race, whether the image depicted a person of color or not. This is obviously a reduction down to a single bit. Does this image depict a marginalized person? Yes or no? There are a lot of potential ways to improve that strategy in the future, but I use this binary categorization because while both race and gender are spectra, in each case, there's a single dominant group that others are marginalized in relation to. And it's that relationship of marginalization that I'm interested in. And finally, after eliminating occupations whose image search results didn't show enough people or people with discernible race and gender, I settled on a final list of occupations. And I made sure that these occupations weren't statistically significantly different from the full list of BLS occupations in demographics. So putting all of this together, what does that look like? Beginning with gender, I had this list of occupations with their real world workforce gender diversity from 0% women to 100% on the x-axis here. And I could then map each of these points to a place on the y-axis reflecting the proportion of women in image search results for that occupation. The diagonal line here would represent perfect correspondence, where the data points would line up if image search results were perfectly reflective of the real world. Above this line are cases where search results overrepresent women, and below where search results underrepresented women. So let's see this data. You can see that these are, approximately around this diagonal line, perhaps a little bit more weight below. We're noticing, for instance, that receptionists are about 88% women, but Google images for receptionists were almost 100% women. On the other hand, women are 30% of CEOs in the US, but only 11% of search results. And women are actually more than half of all bartenders, but only a quarter of search results for that query. Now, doing the same thing for race, again, we have this set of occupations with their ground truth workforce demographics. And again, the diagonal dashed line would be perfect accordance between the BLS and Google. So above is overrepresentation and below is underrepresentation of people of color. You'll notice, by the way, that these axes don't range from 0 to 1 in this case, but rather go up to 40%. That's because people of color are 22% of the US workforce on average. So there weren't records of occupations that were more than 40% POC. And we can again map these to the demographics observed in search images. So what we see here is that for most occupations, people of color are underrepresented in search. Take chefs, for instance, people of color are highly represented in that occupation at 37%, but they're still heavily underrepresented in search. There are, of course, some cases like among librarians where we see that people of color are a very small fraction of librarians in the United States, but Google overrepresents them in search. So to quantify the degree of underrepresentation in both of these cases, I fit generalized linear models to this data, predicting Google's representation from BLS data. And looking at these figures visually, we can see that these models show an underrepresentation of women and people of color relative to the workforce, even more strongly in the case of race than of gender. In order to test whether these predictions of the overall workforce average, these are the vertical dotted lines, were significantly different from the proportional representation of the diagonal line, I examined the model's predictions at that X value and found that indeed these predictions are statistically significantly lower. So summarizing this for digestibility, we could say that for an occupation that's 50% women, this model predicts that images will show 42% women. For an occupation that's 22% people of color, the model predicts that images will show 16% people of color. And in both of these cases, these differences are statistically significant, even more strongly in the case of race than of gender. So going back to this first question, do search results reflect real-world diversity? In this data set, we find that no, images systematically underrepresent marginalized people relative to workforce participation rates. The process, this is sort of a methodological aside, but the process that I used to answer this first research question about the content that sociotechnical systems produce is called an algorithm audit. Algorithm audits are this process of providing repeated inputs and measuring outputs of an opaque system to draw inferences about its inner workings. Auditing, without the algorithm part, is a powerful tool that's been used in the social sciences for decades to identify discrimination in things like employers' hiring practices or loaners' lending practices, for example. And in the context of algorithms, we adapt it to examine whether an algorithm displays bias. So having answered this first research question with an algorithm audit, in this project, I also closed that loop by connecting a second study answering the second question. How does biased content impact users, and how can we do better? So first, I selected a set of 10 occupations, 5 for race and 5 for gender, in which marginalized people are heavily underrepresented. And I chose these because I felt they were among the most high impact examples, since marginalized people might already feel they don't belong in those occupations. Next, I created synthetic image search results pages using the actual images collected in the earlier algorithm audit study. So for each of the 10 occupations, I created 3 synthetic search results pages. One with images predominantly from the dominant group, one with images mostly from the marginalized group, and another with equal representation. And I designed a randomized controlled study for each occupation, exposing participants in the studies to one of 3 conditions at random. After that exposure, I asked participants questions about 3 measures of interest on the 7-point Likert scale. So first, I asked about their perception of how inclusive that occupation is. Second, their interest in joining that occupation. And third, whether they felt they would belong or be valued in it. So what did I find? First, let me briefly explain how to read these figures that I'm about to show you. So the first dimension I varied, gender, is shown here along the x-axis. We can see how participants' perceptions of occupation inclusivity changed as the proportion of women in those search results increased. And in this case, not very much, it's a relatively flat line. Second, in each of those search results, there was also some distribution of racial representation, right? Because you're showing a bunch of faces that have some set of gender and race to an observer. And that's shown here with these 3 different lines that show participant responses on the outcome measure as the proportion of people of color was increased. So reading this figure together, what can we conclude? We can see that greater representation of marginalized groups makes occupations seem more inclusive across the board. So if we read these lines left to right across the figure, we see a slight upward trend that participants' expectations of inclusivity generally increased the more women they were shown. And examining these 3 lines separately, we find that showing search results with greater representation of people of color also had a positive impact on inclusivity. So in particular, showing medium or high levels of POC representation had a positive effect on perceived inclusivity relative to low levels of racial representation. We also validate these findings statistically. So fitting a linear model to this data that predicts perceived inclusivity from these 2 features, both race and gender representation in images had a positive and statistically significant impact on expectations of inclusivity. And you'll note that this is also consistent with prior literature from marketing and thinking about earlier, we were saying that the visual diversity makes organizations actually seem more inclusive to an observer. So next, let's examine results in the same format for the second measure, participants' reported interest in an occupation. Here we see somewhat different results. So while increasing racial representation does slightly increase interest in the field, as you can see from these stacked lines, increasing gender representation actually had a borderline negative effect on people's interest in the field. And again, fitting a model to predict interest from race and gender in the stimuli, we confirm this finding. So in this case, search results with more women had, if anything, a negative effect on this outcome measure. What might explain that? One possible explanation is occupational feminization, which is a set of theories in social science that describe the cultural turn that takes place as women become more represented in the workforce for some occupation, and the closely related idea that pay and other status markers decrease as women's representation increases. So although we might have reason to believe that increasing women's representation in image search results is a normatively good idea, in some cases it could actually empirically lead to counterintuitive and counterproductive outcomes. Now, going back to this setup, there's also one piece missing here. Importantly, in addition to exposing participants to different conditions and collecting their responses, I also collected demographic characteristics like race and gender for each participant. So while these previous 2 results I showed were largely consistent across participants, on issues like belonging, I hypothesized that people from marginalized groups might be affected in significantly different ways than those who aren't marginalized. So next, I'm going to show you 2 findings about participants' sense of belonging, specifically examining differences by the participant's gender and then by race, in addition to the stimuli. So first, let's examine sense of belonging as women's representation was increased, separating participants by gender. As you can see here, women's representation in images had a significant effect on participants' sense of belonging, but that effect was heavily moderated by participant gender. So when shown search results with very low representation of women, men were much more likely than women to say they felt belonging. Then as I increased the proportion of women in those search results, women's belonging increased while men's decreased to the point where they nearly converged. So we find that women's sense of belonging improves with greater representation while men's declines. What this means is that we can actually compensate for some pre-existing differences in gendered perceptions of belonging by increasing the visual representation of women. What it also means, though, is that increasing women's sense of belonging in this way might happen at some cost to men's sense of belonging. And again, fitting a linear model to this data, we see that gender in search results and participant gender both had a significant effect on sense of belonging, as did the interaction of the two. Finally, I did the same analysis for race, separating participants by whether they identified as white or people of color, and examining the effect of increasing racial representation in image search. Unlike the case of gender, though, I did not observe a significant effect of image diversity on participant sense of belonging. Racial gaps in belonging were unchanged by visual representation. So across the board, white participants reported a higher sense of belonging than people of color, and no amount of racial representation in those search results could change that. And again, we confirm this finding statistically. So to conclude, these findings confirm that visual representation in algorithmic content can change people's expectations of the world and of their place in it. But as we saw, there are some important nuances. So first, more isn't always better. Greater levels of marginalized people's representation could in some cases have deterring effects because of underlying social issues. Second, identity moderates effects. The same content might affect people from different identity groups very differently from one another. And third, there are cases where existing inequities simply can't be addressed through some intervention. Technical fixes are not always going to suffice for these kinds of big social problems. So as I've just shown you, I use this combination of technical and behavioral science tools to answer these two questions: what content sociotechnical systems produce and how that impacts users. Underlying that insight that visual representation impacts users, there's a theoretical idea here that I want to draw your attention to. So users in the experiment I just described, as well as in other previous work, aren't consuming search results by scrutinizing each result individually, thinking about what source the image comes from and then deciding whether to adjust their worldview accordingly. Instead, empirically, they consume the entire page of search results at a glance. The whole page is essentially a single object to the viewer. And in my research, I've given a name to this idea. I call this search media. So search media is the combination of headlines, text, ordering, and other aspects of search results on a page that are experienced by users as a single unified form of media. So when users think that search results are largely unbiased, and then they draw inferences about the real world from this mosaic of images in search, consciously or not, they're treating search results as a type of media. This then positions Google in a similar role to that of a newspaper publisher, presenting users with a sort of front page for their query. There are some really interesting legal and policy reasons for which Google would really heavily resist that kind of characterization. But I would argue that the data suggests that this is how users psychologically experience search. So in addition to these policy implications for Google, this also has implications for how we conduct and analyze algorithm audits. Rather than focusing on one part of the search page or weighting the top and the bottom equally, we need to think about how users are actually consuming that content. For example, by considering the whole page and weighting search results at the top more than those at the bottom. This idea about search media and the algorithm audit strategy for studying it has implications in a lot of domains outside of visual diversity. So for instance, another area of interest for me is politics. In the political context, one important kind of representation that matters is the representation of political perspectives. And the potential for bias happens along partisan lines. So in this third project I'll touch on today, I studied political partisanship in search media. This was a sort of hot button issue at the time. In 2018, then US President Trump tweeted about Google, and he made this series of claims on Twitter that of course got picked up in major news outlets around the country, alleging that Google search was biased against conservative perspectives. So amidst that contentious political topic, I was conveniently conducting an audit of political partisanship in web search, and this was a really great opportunity to actually test that idea. So in addition to the previous algorithm audit I showed you. In this case, again, I needed to find a real world data set of importance. So in this case, I collected the names of every candidate running for federal office in the US in the 2018 midterm elections. That's every candidate running for either chamber, the House, or the Senate in any state that year. And then to collect a data set, I built infrastructure to perform queries with those politicians' names, collecting the first page of search results. Scraping this data at scale entails several technical challenges. So one is the risk that Google will identify your irregular activity and block that scraper. Another is that a single machine conducting each of these 3,000 queries wouldn't actually finish in the course of one day. And I wanted to collect these scrapes daily. So to do that data collection of over 3,000 pages of search results every day, I used 5 scrapers instantiated using Amazon EC2 and coordinating between them such that the scrapers rotated through a list of IP addresses and user agent strings to try to make them appear as though the queries were coming from a set of over 20 actual machines. I also then instituted random wait times of about a minute between queries, since rapid queries without waiting make it likely that Google will detect and block your irregular behavior. And finally, each query included depersonalization parameter, as if we were sort of querying in incognito mode to prevent personalization by the history of queries. I wasn't too concerned about other kinds of personalization because prior work had shown that generic political queries like these are actually not heavily personalized. So I then repeated that data collection every day for 6 months leading up to the election for a total of over 4 million URLs. And finally, I used an established metric to label each of these URLs with a partisanship score. So that's a measure from very liberal to very conservative, describing the ratio of liberals to conservatives who normally engage with that website. And I did this with the goal of investigating the set of sources from which search media was being compiled. So from what sources does Google create its search media for these political queries? For instance, if Google was biased against conservative news, we might expect there to be very few sources on the right side of this figure. Or on the other hand, if Google showed very large partisan differences between queries for Republican names and Democratic names, maybe this would reflect some disparate treatment of political groups. Instead, though, what we see is that search media actually drew extensively from conservative sources, regardless of query. As you can see, this pattern looked roughly the same, regardless of the affiliation of the candidate being searched for. So at least by these metrics, we concluded that there wasn't some widespread bias against conservative content in search media. In other words, algorithm audits can also identify cases where there isn't evidence in support of some alleged bias. So you'll remember I said I collected this data daily for 6 months leading up to the election. I had originally been interested in whether there were temporal changes over the course of the election. And I found some evidence that political events that affect individual political candidates changed their search media. But rather than going into that here, I'll just touch on one striking trend across this whole data set. So here we have the average partisanship of each page of search media, weighting each individual search result by its order on the page. So a page of more partisan search media would be a data point higher up in this figure, whereas a more moderate page would be lower. And let's look at partisanship over the course of the election for one obviously really important outcome measure of interest in elections, candidates who went on to win elections versus those who lost. As you can see, search media clearly differentiate these two groups. So election winners have more moderate search media than do losers. Now, before you get super excited and quit your PhD to start the next 538 election prediction service, I have to tell you something that political scientists recognize really well. It's a well-established fact that election outcome actually has a really strong correlate, and that's incumbency. So incumbent candidates win upwards of 90% of the time or even more often. So if we separate candidates out by incumbency instead, we actually find that this is the main driver of that trend. Search media differences reflect incumbency. Incumbent candidates have much more moderate search media than do challengers or those running for open seats. And this finding empirically demonstrates a pattern that's been theorized in political science, that challenger candidates whose road to electoral success involves first winning a primary election where only members of their own party are voting, are incentivized to take more extremely partisan positions. Whereas incumbents who are looking to win a general election where citizens from both parties will vote should take care to come across as more moderate. And we see that reflected here in search. So in short, our findings from this study demonstrate that algorithmic content reflects real-world information and reveals insight that speaks to theories from other disciplines like political science. And overall, algorithm audits are a multi-purpose tool for studying bias in socio-technical systems. Without going into it too extensively, I want to just make a quick note here on algorithm auditing. As we've seen, conducting effective algorithm audits is technically challenging. So what to measure, how do we collect that data, how do we manage it at scale? And at times it can also be theoretically and ethically challenging. So it usually involves breaking a platform's terms of service, for instance, which historically has been illegal. So recently, I and a team of algorithm audit researchers from 4 universities have written an authoritative piece on algorithm auditing, covering its history, best practices, ethics, and norms. And that piece is coming out, I believe, next month in the journal Foundations and Trends in HCI, if you're interested in learning more. So as I said earlier, there are these 4 key challenges to studying sociotechnical systems. They are dynamic, ephemeral, embedded, and personalized. And research like mine closes this loop, connecting the socio and technical parts of these systems using a combination of computational and behavioral science strategies. But the overhead to doing this kind of work, as we've seen, is really significant. So for each website we want to study, we need to build new custom infrastructure, and that infrastructure only allows us to study one website at a time in general. And in order to control the stimuli that users see, we have to run experiments in highly controlled artificial experimental settings. So in order to enable more researchers to do this work and to do it sustainably, in addition to creating guidelines and best practices, we also need more effective tools. And the need for tools brings me to this final project, creating infrastructure for intervention audits. So while there are existing tools to do such research, they have really significant limitations. There are many examples of one-off infrastructure for passive audits, as we've seen in this talk. And these can be really valuable, but they generally only collect data from one website at a time. New infrastructure has to be built for each new audit, and any experiments or interventions need to be run separately. Another option is panel survey data collected by private companies. This kind of data can be reanalyzed by researchers who don't have to collect it all from scratch, but in such logs, we can only see what websites users actually visited, not the images, the headlines, or other content that they consumed without visiting some new URL. And these data sources also don't allow for experiments and can be really expensive to get access to. And finally, I think some of the most promising work in this space has been proposed by Mozilla, who are right now developing a tool to let researchers collect data and run experiments in the browsers of volunteers. This gives the researcher a lot of control and allows for interventions, which is great, but users will have to tolerate these on a volunteer basis. And so this kind of limits the kinds of interventions that Mozilla can run. And researchers also can't follow up with participants through surveys or other kinds of additional data collection. So going back to these challenges, ideally what we want is to allow researchers to collect data themselves in real time, to do this for extended periods of time, perhaps following up with the same users later, to allow them to choose exactly what data to collect from user browsing across all websites, and to combine this auditing with interventions on consenting participants. And this is Intervenor. Intervenor is the last project that I worked on during my PhD, and it's a system that's designed to allow researchers to both passively audit and also intervene on the cross-site browsing experience for a group of consenting and compensated participants. So the system has 3 parts. The first is the front end, a Django web app. The second is a Chrome browser extension. And the third is the back end implemented using AWS relational database services. And I'll explain briefly what these 3 parts do. So the front end is user facing with an admin interface for researchers. It handles onboarding and offboarding. It collects survey responses and gives users privacy controls for their data, and also allows researchers to manage participants. The extension then handles data collection, collecting the trail of links that participants visit online, timestamps, and also content on the page, customizable by the researcher. So this could include images, headlines, links, or other content viewed by participants. And the backend combines and securely stores these 2 data sources where researchers can access them later for analysis. To make this a little more concrete, I'll walk you through Intervenor's use from the perspective of a participant and then of a researcher. So from a participant's perspective, their experience of Intervenor has 3 parts: onboarding, participation, and offboarding. During onboarding, they're consented and they complete an onboarding survey, and then they're walked through the extension installation process. During participation, there are 2 phases. First, the extension passively collects data from their normal browsing to establish a baseline for each participant. And during the second optional phase, the system deploys interventions, changing their browsing experience. And finally, after their participation is over, they uninstall the extension, complete an exit survey, receive payment, and can potentially be contacted with follow-ups in the future. From the perspective of the researcher, using Intervenor involves development, recruitment, and management. So during development, rather than build this whole infrastructure from scratch, the bar for entry is lower. Researchers just need to be able to edit the existing code to collect the specific data they're interested in and deploy their own interventions. Next, they can generate participant codes to allow users to sign up, distributing them through ads, survey panels, crowdsourcing platforms, and wherever else they're getting their participants from. And finally, during the experiment in management phase, they can do things like randomly assign participants to different experimental conditions and collect and analyze the resulting data. To make these benefits clear, let me walk you through two examples of studies that Intervenor can enable that are beyond the current state of the art. So the first is the domain of fake news and misinformation. There's been a lot of work in this space in the past few years, including an excellent recent paper that analyzes browser history logs published by Allen et al. In Science, which concludes that people visit websites with misinformation very infrequently. But Intervenor allows us to go further. So first, in terms of exposure, what headlines do people see but not visit? Browser history logs only record the sites that people do visit. In contrast, Intervenor can collect data on each page of a user's browsing and study things like selective avoidance by examining all the links that people see and don't click on. Next, Intervenor is user-centered. So in addition to log data, we can deploy surveys or do interviews to understand how people's beliefs change over time in relation to the content they consume. Unlike history logs, Intervenor has built-in capabilities for this kind of additional data collection that can help us better understand the user's experience. And finally, interventions. So in addition to studying search media or media consumption patterns as they are, Intervenor can give us the capacity to run ecologically valid experiments. For example, periodically prompting users to do something like focus on content accuracy, which other recent work suggests is a promising strategy to counter misinformation. Following that work, I'm also going to be reusing and extending Intervenor to study bias in online advertising. We've probably all noticed or heard at this point that marketing and branding is and has been kind of forever really heavily gendered. And related concepts like whitewashing describe the way that dominant norms, like what's considered attractive or presentable, professional, or marketable, these are racialized, and they affect the way that we see race presented in media like movies and ads. Moreover, the content that we see in advertising should have some psychological impact. That's kind of the whole point of advertising. So given that backdrop and the harms that I've shown you that can occur from biases in gender and racial representation in algorithmic content, I'm interested in whether online ads shown to people also display such biases. Existing work has found that from the perspective of an advertiser, online advertising platforms don't have sufficient safeguards in place to prevent advertisers from racially targeting ads for things like housing and employment, though it's illegal to do so. And similarly, that ads for things like STEM careers might not be shown equally to men and women. But if we wanted to study the set of ads shown to actual users, current algorithm auditing techniques fall short. So as you've seen, most audits collect data from a single website, and that data is kind of presumed to be a good stand-in for what all users see. But in this case, we know that ads are shown to people across the whole web, and they're heavily personalized. So again, Intervenor improves on the current state of the art. First, on exposure, Intervenor can collect all the ads that people see in browser and get a full picture of the content of those ads. So for instance, we can look at things like the distribution of gender and skin tone in ads and ask whether these are representative of diversity. Second, Intervenor will deploy to a group of real users, and it will collect the ads that they're shown across all the websites they visit, allowing us to study those repeated exposures in the context of the user's own demographics, to understand, for instance, whether people of different races or genders are shown significantly different ads or affected by ads differently. And finally, we can also experimentally change the ads that people see to causally demonstrate the effect that these kinds of ads have on people's perceptions of technology and of themselves. The last point I want to underscore here about the system is the importance of privacy. Research practices from academia as well as industry have led to major tensions in recent years when users are unaware that they're participating in experiments and unable to opt out. So keeping that in mind, Intervenor is designed with participant privacy as a central value. This includes consenting and compensating all participants, providing those participants with controls over the data that we collect, including an interface for data redaction and incognito browsing, and securely and anonymously storing their data for a limited period of time. I'm in the process now, having run, I think, 1 pilot study, 1.5 at this stage, and I plan eventually to release this tool publicly, allowing researchers rather, to run studies that are hosted in the Intervenor environment. I think practices like these are really necessary for making this research sustainable and creating trusting relationships with participants who we can work with again in the future. So to summarize, over the course of my PhD, I worked on studying representation and bias in socio-technical systems, including these 4 projects I've talked about today. The first 3 demonstrate the impact of combining computational strategies like algorithm audits with behavioral science to identify bias in algorithmic content and its impact on users. So first, I showed how psychologically inclusive versus alienating design could impact people's sense of belonging in the context of some course. Second, that racial and gender biases do appear in algorithmic content and can have detrimental effects on people in the context of employment, and that different levels of representation can cause both positive and negative psychological responses. And third, that building systems for auditing bias in algorithmic content can also be a useful tool for studying other types of bias and in cases where some alleged bias isn't observed. But this kind of content can in fact reflect real world and theorized trends. And finally, Intervenor takes this one step further, providing what I think is much needed infrastructure for more researchers to be able to conduct this important work in an accessible and scalable and sustainable way. Sociotechnical systems and the algorithmic content that they produce are going to continue growing as one of the main sources of education, professional opportunities, civic engagement, and more. So when we study it, it's really vital to consider both sides of this equation, the system and the user. And that we do this keeping in mind and in focus the experiences of marginalized users. This is the central thesis of my work. So by closing the loop between algorithmic content and its effects on people, we can build socio-technical systems that have positive impacts on ourselves and on our communities. Thank you so much for your time and attention today, and I'm really happy to take any questions either now during Q&A or by email.
Yeah, thank you very much, Danae. Anybody who is in the room should be able to just speak and the microphone will hear you. We're also getting some hands raised in the Zoom, which I can, we should be able to unmute. I can actually.
I have a question. Thanks for the talk, first of all. I was thinking about the first figure you had on the political partisanship. So like, I think you counted the number of unique sources on the search page to determine like whether it's right-leaning or left-leaning, the search results. Do you know, or how do you feel about like counting the number of unique sources as the metric for this?
This one. Yeah, and this is kind of an abbreviated version of all of the rest of the analyses that we did in that paper, sort of for length. We counted unique sources. We also looked at repeated sources. We weighted based on order on the page. We looked at it without weighting based on order on the page, and a bunch of sort of other visuals like that, and kind of found the same trends across the board, which is just that there was pretty consistent representation of sources, liberal and conservative sources in the data set, that this didn't look different based on the partisanship of the candidate being searched for. And so kind of, yeah, this is one limited metric for studying that, but we found results that were pretty consistent with that information.
Joyce, did you have a question? Are you able to unmute yourself? If not, you can list it.
I had a reaction, but it wasn't intended as a question.
Okay. Any other questions from online? Okay. Well, giving them a few minutes. I had a question about, you mentioned automatically labeling the data of the image results to ascertain membership in like underrepresented classes. With a lot of stuff I'm seeing with computer vision, there's issues where it performs less well on like people who aren't white men. Did you have like ideas on how to get by that, or just like how you handle the response?
Yeah, this is a great question, and I could really talk about this extensively. There are a few different issues at play. One is that from what we've seen in computer vision, in machine learning, there are a lot of cases where this kind of automated labeling is being used in ways that I would describe as somewhat unethical. But in addition to that issue, which is sort of the low-hanging fruit, like, it's obvious that in some cases you probably shouldn't be doing this kind of annotation, especially as you mentioned, when there's sort of like low performance on whole groups of people. But on the other hand, I think there's also cases where doing automated labeling is sort of answering the wrong question. I've seen a lot of papers, for instance, that are saying like, oh, we're interested in, I don't know, what's an example, like citation bias. How many times do papers get cited based on like the gender of the author name? And then like, in order to figure out the gender of these names, we're either gonna like, we're gonna start by just trying to do some automated labeling of names. And then like in all the cases where we can't label, we're gonna go and like label people's faces, look up those authors and label their faces. And so there's so many examples of work that's like this. And I don't know if you've noticed, but like in that second stage, that answers the wrong question. If you're interested in how someone's name is being perceived and it's not clear the person's gender from that name, then like that's the whole point. It's just not clear. Like it doesn't make sense to go and say like, but what does their face look like? Because that's not the kind of bias that you hypothesized existed. So, I'm actually in the middle of working on a paper with a lawyer, Kendra Albert. And so they and I are working on kind of outlining what sort of a taxonomy of the ways that these sorts of automated labeling techniques get used, noticing that in many cases, sort of there's this mismatch between the type of labeling technique that's used and the question that they're trying to answer, that researchers are trying to answer. And then also kind of laying out some guidelines for when we think it's appropriate to do this kind of automated labeling. And that includes things like verifying that there's good performance across the types of groups that you're labeling. It includes cases, we think that explicitly they should only be used in cases that are sort of attempting to remedy some existing inequity. Because like, while there are a lot of problems with this kind of technology and widespread use, it's still important to try to quantify and measure discrimination and bias, at least in our opinion. So yeah, we have this project that's kind of in progress working on that. And so in my own work, this is like a strategy that I think it's possible to use some automated techniques in some cases, but it really opens a whole separate can of worms that I didn't really want to get into with that specific project. I guess the other point to make also there is that like who the person perceiving that name or face or whatever is makes a big difference. And really excitingly, there's some recent work that was just published showing that indeed different people based on on an individual level, but also on the group level, different groups of people are actually like significantly different in their labeling of these sorts of attributes. So, whether you come from some group or, you're like an in-group member or not, might actually change how you perceive a face or a name and so on.
Thank you. Other questions? So one other thing I was wondering is with auditing the algorithms, there seems to be a somewhat adversarial relationship with like their spam detection. Is there a way past that, or is it always going to be like a race between the two of you to like try to get past them versus try to prep them?
Yeah, this is an excellent question. And actually we have like a section of this in the paper that's coming out next month on algorithm auditing, specifically addressing sort of other models that are possible for audits. Some academics have proposed things like a collaborative audit where you actually work with the company in question and produce that audit with like inside access to data from that company. Because again, like setting up this infrastructure, running these audits is expensive. So you kind of need someone to financially underwrite yourself in some cases. And also like it can be hard to get access. So having an inside sort of angle can be helpful in that way. Separately, also some types of audits are conducted at this point. There's like a few companies that are offering this as a service where you can, if you're some company and you want to sort of proactively check your tool, you can hire one of these companies to do that audit for you. In this algorithm auditing piece that comes out next month, we sort of detailed why we don't think these are good solutions. Because while the relationship doesn't need to be inherently adversarial, you do need to be a neutral third party to conduct these audits in a way that is sort of maximally trustworthy to an outside observer. So, unfortunately, yes, these are resource intensive to do. They are difficult. It's difficult to get access to the data, and it can be expensive to collect and store it. But if you're doing that while being paid by the company in question, we've already seen examples of companies that are sort of hiring some auditors in order to sugarcoat their tool, and sort of are then like publishing findings that are like not really reflective of what the auditors actually found. Because this is kind of a fraught space that like inherently has this tension between the financial interests or the PR interests of the company and the people who are trying to audit. Yes, essentially, I think it is important that you have sort of an independent third party. And right now, that makes it kind of adversarial. I think in the future, we're trying to move. There are many people proposing this now, and that's sort of like new as of the last few years, trying to move towards maybe doing this at a governmental level. So if this kind of audit was something that governments were doing, the same way that they, audit your tax returns, that could be a format in which it's not sort of quite as adversarial, but it still allows for an independent third party to be doing audits.
Thank you. Joyce?
Yeah, I kind of remember had two questions in the background. So slightly unrelated. One, I was curious if you had thoughts on how, I guess the groups that are being audited, whether they're companies or other systems that are developed, how they may use the results from this and like actually implement them in practice, because like you mentioned, it as of right now, it does seem like it's a little bit adversarial.
Yeah, so like one really concrete takeaway here, at least the thing that I'm trying to promote in my work, is that in the past, there's been sort of the style of audit that's like, look, we found this discrepancy. And then like we try to apply pressure to Google or whoever else through publicity to try to get them to like adjust something about their algorithm. In some cases, maybe manually change the results for certain queries in the case where there's like hate speech or something, this might be appropriate. But it's kind of this it misses that second piece of the puzzle, which is like, how do people actually respond to that content? So the thing that I'm promoting the most in my work is that it's not really about the specific findings of some audit at some moment in time, but rather the entire process that involves first doing measurements of the content and then doing measurement of impact on people. Because we can see sort of cases where there's some counterproductive, counterintuitive outcome when we actually look at how this affects people. So it's really, I think it's limited to just do an audit, see some breakdown of content, and then like apply PR pressure to try to get the company to change the content itself without understanding what the downstream effects of that are going to be.
And then I think another thing that was not quite related earlier is when you were looking at a breakdown of like search results, I was curious if there may be variance in like the impact of the ordering of different results. Like you mentioned, it's kind of like a holistic experience.
Yeah, it definitely does. Search result order does make a big difference. It makes a huge difference in what people click. So when you're looking at behavioral metrics, like what content people follow up with, I feel like the first result is like maybe 30% probability of getting clicked, and it sort of like decreases from there, but like pretty exponentially. And also, when you look at, there's tons of work looking at this, behaviorally in terms of what people click, also in terms of doing eye gaze studies and thinking about like where people are looking on the page. Also, like their attention is focused towards the top. So yeah, there's like a whole body of literature examining like that specific question, and the conclusion is like order matters a lot.
All right, thank you.
Yeah.
Thank you. If there are any other questions, I think that's what we did. It's 4 o'clock and we don't want to keep you too too long. So thank you very much for this wonderful talk.
Awesome. Thank you so much for having me. And I look forward to meeting hopefully some subset of you next year.